Evet, bugün 2022 30 31 Ekim
Hello there. Welcome to the stream. Oh my goodness. Is this thing? Oh my goodness. So, Twitch did something to their stream manager, and it just constantly eats the freaking chat box. Like, every time I refresh the stream manager, the chat box is just gone. Oh my goodness. Let's go back to plan B, I guess. Thanks for the follow, Craig MCC6. Preemptively mute that tab. And then I go to pop out chat there, and I guess I'm doing it this way. Because Twitch chat doesn't work. Okay, I have my Twitch chat window set up right to the left side of me. And let's do this. But hi. Welcome to the stream. Today I'm going to be working on my over-engineered cluster manager. Good morning, Kuforuzu. It's just after the morning here. But I guess if we're going by a universal greeting time, then it is the morning, because we say hello. I've not seen the talking profile pic approach for VTubing before. Yeah, this is a hack. You know what? Let me see if I could. Let's see what happens if I layer my VTuber avatar over the crappy overlay. Or just remove the crappy overlay entirely. Oh, that looks kind of awkward. Is waifu diffusion your own local fork of stable diffusion? No. That would be something that I do, but no, it is basically just stable diffusion, but retrained on Danboru and Pixiv. So what was my to-do list for waifu-D? Waifu-D progress report number 2. Thanks for the sub, Saku. Do I have a recording? Oh, I don't have a recording. I am a professional adult, and I remember to hit the record button every time. I say, lying to myself to make me feel better. But yes, for those of you watching from YouTube, I am going to be working on making waifu-D better. Waifu-D is my own... is my hacked up cluster manager. It's it basically exists because I bought too much hardware. Let me see if I can make the terminal window taller to fit. Oh, that's nice. If I make it wider, okay, it doesn't do that. But there we go. I think that'll work. Will it? I don't know. Move you down a little. Oh, I should probably have made a variant of this because it's also the one that I use for Elgato streaming. Oops. Ah, well, I can fix it later. Duplicate streaming Elgato. There. Fix it later. Hello, size of underscore your mom. Welcome to the stream. So let's switch over to the Isekai-D branch and get rebase main. And then push that to the cloud. Okay, so today I want to work on the metadata server named Isekai-D. Isekai-D is basically intended to sort of be like... It's supposed to sort of just be like the metadata service on AWS, except local to waifu-D. And I use a remarkably hacky way to deal with it by making a WireGuard what's it called? I make a network stack in user space, and then have that network stack connect to the kernel over WireGuard. And then that's how it gets the magic IP address of 169.254.169.24. What's a metadata server? Okay, so... you know what? Let me fire up a VM on AWS real quick. I can show you. But basically, the metadata server is something that like lets an instance know like what's its deal. You know how when you let's say that you make a VM with DigitalOcean and you put your fucking what's it called? You make a VM with DigitalOcean and you select the SSH keys that you want to use with it. The metadata service is the thing that tells the machine, oh, hey, you should use these SSH keys. It does this through, you know, complicated means with Cloud Init and whatnot, but the important part is that there's a metadata server in the equation, and that is what I want to have in waifu-D because it's an interesting problem and I can use it to make interesting things like, I don't know, have an automatic discovery way for machines to grab like AWS keys or something. Okay, my verification code. I have a software development interview on Tuesday. Good luck. Those are always. Is it your first for your first software job? That's always scary. Okay, US East 2. Let's launch an instance real quick. Architecture, ARM. Let's go with smallest they have. Just so that I don't... T4G.micro. Okay. TypeScript. Makes sense. Yeah, in AWS and Azure, it also does things like handing out access tokens for the cloud. Yes. That is another one of the very important things that it does. Oh, I have to create a new key pair. And I'm going to create a key pair name, and we're going to call it waifu stream test. Create key pair. Oh, and then I get the PEM file. Okay. So scp downloads waifu stream test. Oh, wait, I should do that in here. cp downloads waifu stream test.pem kd at numa :ssh. And then we'll set the permissions of that private key so that only I can read it. And then we'll add it to the SSH agent. There. It's in the SSH agent now. That's good. And now it's like, holy crap, you're trying to make it accessible from anywhere on the internet. What are you doing? Let's go with 10 gigs for the root volume. We're going to use Amazon Linux 2. And hit the Launcherino button. And you know what? Let's see if that worked. Copy the IP address. Okay, so now if I right-clicked and I choose connect. Oh, my username is ec2-user. Okay, so hey, cool. Just gonna do a quick update. Not totally needed for this, but you know, it's good practice to update things. AWS metadata service. I'm gonna pull up the docs over here so that I can, you know, not totally make things up. I'm just gonna be partially making things up. Okay, curl. We have curl. Okay, so in AWS, in order to see what you can get from metadata, you curl this IP address. So in a way, we can pretend that this IP address is run by the hypervisor, and it basically gives you, you know, information about the instance, like host name. yeah, so we get the host. What the host name should be in this case is just the default generated one because I didn't enter one in when I was filling this out. We have local IPv4, which will tell us like the IPv4 address of the local network, which we can confirm with ifconfig. Yeah, so we see that we got the local IPv4 from here, which is arbitrarily assigned by AWS, and we got the local IP address that's configured here. Or we get the public IPv4, and we get the IP address that I SSH'd into. And we can see what security groups it's in. Launch Wizard 1, which again is because I literally just created this in the admin panel. But yeah, the AWS metadata service is really kind of interesting. Actually, I should window capture, call it Stream Edge. Oh, cool. So then make this bigger. Yeah, it basically just lets you get all of the instance metadata. And recently AWS realized that making the metadata service unauthenticated is kind of a bad idea, but at the same time you can't really make such a thing authenticated easily, so they work around it by making you get a metadata token. I believe you can set policies how those tokens are minted, but you can only do so much. And in general, this will let you get the SSH keys. So if we go here, then we can take this URL and hide Edge real quick, go over to here, and we'll see that we get the public SSH key that I just created for this thing. And CloudInit will use this in order to dynamically generate the configuration for the system so that you can go from a brand new copy of Ubuntu to something actually usable. However, the AWS metadata API is kind of complicated for what I want to do, so let's take a look at how DigitalOcean does theirs. And maybe Vultr for good measure. No, we don't want to get the SEO spam. We want to get the official documentation when at all possible. Maybe this Go repo will have a link to the documentation. Ah, okay. So it is literally just on vultr.com/metadata. So, as you can see, it really just does give you, a whole bunch of metadata about the instance. Which is also viewable as, a bunch of, specific things. And for some reason, this lets you see the BGP peering information. I didn't know you could do BGP peering on Vulture. That's kinda cursed, but I'll deal with it, I guess. These are all very complicated, actually. Maybe I do want something just a little bit simpler. Because all you need to do is use some format that Cloud Init accepts, right? Yeah, that's kind of what I have now. isekid.go. So actually, let's spin up a quick VM to show you what I'm getting at here. So let's spin up a quick Ubuntu instance. So I'm going to spin up an Ubuntu 20.04 instance on Cosmos with 1024 with 1 gig of RAM and 25 gigs of disk. I leaked one that I actually invalidated, don't worry. I was using environment variables for testing, but I am not anymore. I did not leak a valid key. So let's create this one real quick. And with the fury of Rotbart, it is now creating machines like Nick's Duskull, which, as you know, makes my trollish heart smile. Then we go here, paste. Port 22 connection refused. Oh my gosh, why is this happening? Okay, that shouldn't happen, but let's just work around it for now. So, I forget how to see this, but there's something that lets you see the, DMI decode, that's right. Oh. Here we go. Okay. So with Cloud Init, it has this concept of data sources, which are Python classes that do generally horrifying things to get the data that it needs to. So this one that I'm using is what's called the NoCloudNet data source. And I set the source to, you know, this Tailscale IP, which is reachable from the hypervisor because I am making poor life decisions at the moment. This is why I want to replace this with Isekid, because doing these lookups directly is kind of bad. If you can guess what the like instance IDs of other waifu instances are. But basically it fetches things from here. So if we do curl user data, you know, we get the config that it baked in. If we do meta data, we get the instance ID and the host name, and I don't think I have vendor data. Yes, I do have vendor data. What this vendor data thing will do is it will add a welcome to Waifu D heart little thing here. And basically I want to put this behind Isekid so that I don't have to expose this, you know, potentially to other things. So let's try it out. How did I launch it? B dot 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 dot. Ah, right. Go build this backwards. Ah, yes, I have done this before. Okay, so what this command is going to do is it's going to build isekid to the var folder, and then it's going to run it as root because it needs to run as root for reasons involving managing the network stack. I'm probably going to remove that in the future, but for now this is the case. So you run that, and isekid prints some stuff when it's running. What is the and command? It's a fishism. Basically, the and command will it's the moral equivalent of and in fish. What was it? Okay. So if I do curl, or no, I need to do this on Numa. Oh, it does support and now? Oh. I feel like an idiot. So we make Joe Cranch. Forgot that I need to actually run this on the machine that I'm testing stuff on. But as we can see, it created a new interface called waifud metadata. And this side of the interface has 169.254.169.253. So what we can do is we can ping the other side of that, which is the Go program. And you know, we get all of these beautiful ping responses from this up here. And if I Control C, then we won't get any more ping responses. But if I start running it again, then we get ping responses again. Let's hope that that worked. It did, okay. Ah, right, I haven't patched this to use isekid yet. But you know what? Let's patch this to use isekid. So with waifud, normally we have the URL for this looking like, you know, the path to waifud's API server /API/cloudinit/instance name. So let's try curling it directly. .254.169.254 instance / metadata. Awesome. So then now that there's metadata, let's try this. Okay, so I generate the XML for libvirt from this template, which is kind of terrifying. Okay, the seed is a variable that's passed in from the template. So to edit that logic, we need to go into source, API, I think it's in instances. Ah, yes, this is the create instance route. Okay. So we have this new instance which has all of this crap. And then there's the part where it makes a whole bunch of inserts into the database. And then we call make underscore instance. Okay, and then we check if the image exists so that if it doesn't, it can get downloaded. And if it fails, then, you know, you get an error and it SSHs back in to delete it. And then it updates the status so that it's hydrating the ZVol. Oh yeah, I use ZFS everywhere. ZFS is the secret to how all of this works because I'm using ZFS ZVols for block storage, which means that all of the VM disks can be treated as ZFS volumes, and you know, you don't have to think. So http://169.254.169.254. Snapshots and rollbacks too. Oh, yeah, there's also another thing that this does. When you create a VM, it will automatically, after it hydrates the volume, it will automatically create an init snapshot so you can go back. In the future, I want to expand this for like more arbitrary snapshots, but for now, this is fine. Okay, so that rebuilt with all of that, so... Delete Joe Cranch, you were a good soldier. And let's delete Nick Duskull, because you were also a good soldier, but we don't need you anymore. So let's try this potentially broken branch of Waifu-D and, you know, create those rules. You get Alejandro Aloha. I love this new name generator. It's so freaking unhinged. I love it so much. So now we should see a log message here when the machine boots up. And hey, there we go. We get metadata, user data, and vendor data. Awesome. It's working. Once this whole energy crisis thing is over, I'm going to spin up a server with ZFS. Xeons idling at 130 watts 24/7 is a bit much. Yeah, just a little bit. But let's see if this worked. Hey, we're in. And just to check, just a triple check. All right, okay, so at the very least, Isekai is a replacement for the current state of the world. However, this is boring, and maybe we can do this a bit better. So, one of the other complicated things about all of this is the fact that when we were in the AWS VM, we didn't have to specify what our instance ID was. It was just able to, you know, figure it out based on the remote IP address. Let's try and see if we can do that. But that might require a little bit of thinking how this whole process works. Let's delete Alejandro Aloha. Let's make a document called design for Cystic ID. Okay, let's start with some bullet points, because on this channel we love ourselves some bullet points. We should have Cystic ID be a metadata service. It runs on every machine. Looks up instance information by remote IP. Actually, you know, that's a good thing to think about. So when Cystic ID is running, it gets a connection from somewhere, but we don't really know where. So let's find out where it is. So what this does right here is I have every HTTP request in Go, there is a remote address field, and that's a string containing the IP address and port number. So with this right here, I'm calling the net.splitHostPort function to, split the host and port out so that we can see what the remote IP address is, so that we can understand, what fresh hell we're into. So I'm gonna go build and restart Cystic ID, and let's make a new waifu.d VM to test this out. So now I believe it should use the VM IP address, unless I am horribly, sorely mistaken, in which case it will not, and then we probably have a problem. .169. Oh, it's not using the VM's remote IP. Wait. Oh, right. Oh my goodness. I know what's going on. Okay, so... what is the thing I'm looking for? Net-list, right? Okay, so... what you're looking at here is the XML configuration for the default network in libvirt. In libvirt, the default network is like basically where all of the the default network that all VMs are dumped into. So in this case, what we have is we have forward mode equals NAT, which means that we're doing NAT forwarding for everything. That's potentially bad. To ~/. So, oh, I could use my fancy IPv6 prefix. Yeah, we could use an actual internet-facing IPv6 prefix here. Yeah, that's 64 bits. Okay. So, is there a way to do like an IP tables rules for like NAT accept something? Okay. Actually, I'll move this over here so you can see my research. Okay, yeah, there's network address translation going on here. So, let's see what the IP tables rules that it's configuring actually are. Ah, yes, -S, okay. So... Okay, so we have this IP tables rule here in the chain libvirt.forwardin, where it will take the destination to this one. It will track the connections, I think, and then accept the thing. Otherwise, it will use ICMP port unreachable. And then it adds a whole bunch of exceptions for ports 53, which is DNS, I think. Port 67. What is port 67? I'm thinking that's DHCP. Oh, it's boot P. Okay. 67 is boot P. 68... Okay, yeah, it's DHCP. Okay. Makes sense. So, basically, allow DNS and DHCP. Okay. Not sure where it's doing the masquerade step, though. Because I actually do need this to do the masquerade step in order to, like, you know, connect to the internet. Let me send a request to a networking expert. There, I'll send out that request, and let's do some looking in the meantime. So, let's just look what a libvirt network is, I guess. So, it's basically a virtual network switch, yeah. The NAT is set up using IP tables rules. Okay, contract. Is that another form of NAT? Oh, it is. Okay. Okay, there's also isolated mode where guests on a virtual switch can communicate with each other and with the host, but you can't go to the internet. That's not what I want. By default, it's in NAS mode, which makes sense. In NAT mode, which makes sense. I'm really hoping I don't have to be a DHCP server, but it's looking like I might have to. Actually, you know, come to think of it, if ISAKID was a DHCP server, that would make a whole bunch of this simpler. because a lot of this complication is coming from the fact that we're dealing with, you know, the DHC, the NAT and DHCP configuration that's on the host or in libvirt. Maybe it would be easier to, like, not? I don't know. What are you thinking in the chat? I have no idea. At least you're honest. Oh, thanks for the follow, size of underscore your mom and lock23r. You know what? Let's do the biggest struggle hours and let's send out a cry for help on Twitter just in general. Okay, forward that, and then spanning tree protocol? Why would I need to do spanning tree with virtual machines? That's cursed. Oh, okay, so there's a net edit command that I can use to edit the network configuration directly. Let's try that. Probably helps to show my terminal. This is probably a mistake. So, if I understand what's going on here, I wonder if I've just created a way to get a VM on the IPv6 internet. Maybe IPv6 will have different rules here? Actually, wait, I did only look at the IPv4 rules, so IP6 tables -s. Port 547, that feels like it might be some kind of thing. No, it's still using the old network thing. I'm not sure writing a full DHCP server would be simple. Okay. People have already written DHCP servers in Go that I can take advantage of. I mean, you could add a static route, right? Yeah, there's DHCP v4 servers in Go. Go.universe.tf. Oh! Oh, this is by a friend. Yes. This probably is gonna work. Oh, it's building blocks for DHCP clients and servers. Deprecated, use serve. Okay, so there's a handler. And example using DHCP with a single network interface device. So we have a server IP is this. We have a handler. Would it also not mean you need to smuggle back the metadata in DHCP packets? No. So there's other bits of metadata that we have here that I haven't mentioned, but the biggest thing that we have is the MAC address. Because, you know, it needs to get a MAC address somehow, and by default, I have it automatically generate a new MAC address. Where's the MAC address? MacAdder.clone, where is Mac? Oh yeah, random underscore Mac, okay. Ah, right, I put that in libvirt.rs for some reason. No, I put that in that libvirt.rs for some reason. But yes, this function right here will generate a new valid MAC address in the private use range, where you basically take a random 48-bit value and you bitwise and the first digit in there like this, the first byte in there like this, and it is guaranteed to be very unlikely to collide with something. Well, without even knowing the MAC, how would the HTTP server know who is connecting? Okay, so from the MAC address, you can get to the instance ID. Yeah, so if we have the MAC address like this, then is it really safe to keep instances per MAC address? I mean, this is what AWS does. And I'm pretty sure it's what DigitalOcean and Vultr do. So I'm pretty sure it's safe. At least I hope to God it's safe, because if not, then, you know, the way that the entire cloud is doing it is probably wrong. You would need layer 2 forwarding to preserve the MAC address, right? Can't be layer 3. Okay, so the lookup path here is ESIC-ID looks up the MAC address in the DHCP client table. It sees what the IP address is, and then it queries that. It gets the IP address from the incoming client. It queries that in its local DHCP table, and then if it matches, then it will contact WaifuD and ask it for instance information. So let's write that out. So to the DHCP client table, also browser is in front, crap. Also, what is our threat model to be exact? I'm not worrying about a threat model so far. Okay. So, actually, do I need to have this? Yeah. We need the non-natted IP address here. Yes. I'm treating that as a boxed problem where I'm not caring about it too much right now. Like, it's a thing, but I'm not worrying about it super much. So my other thought is that, okay, DNS mask is kind of noisy. Maybe we can look for DNS mask logs in order to figure out, like, what address that it thinks it's getting. Why we need a non-natted. If we have that solved, then this makes sense. Okay. Oh. Okay, so we have DHCP discover for this, and we have DHCP offer. Okay, what is the journal cuddle filter for program? Filter by program name. Okay, so I use -f _ com equals that. So yeah, there's a whole bunch of gook in journal cuddle by default that nobody really knows exists. So what I'm going to do is I'm going to reinit that thing, and then we're going to see where that is. Topology change. Tailscale is saying something. It's in libvirt. We have DNS mask. But okay, so where's the _com here? Yeah, journal D is like incredibly freaking structured. It's kind of impressive. No. Go to jasonprettyprint.com. So by parsing the logs, we can get the mapping, and as long as the parsed log data is sufficiently up to date, we will know the pre-NAT IP to MAC address translation. Yeah. It's kind of horrific. and it will probably involve needing to like serialize this to the disk somehow and, you know, get it back. JasonPrettyPrint.com doesn't exist anymore. That's a shame. So _com is DNS mask. Yeah, so we can get all the DNS mask stuff like that, and we can turn off JSON output. There we go. What was the other stuff in the output format? JSON server sent events. Okay. Oh, output fields. Oh. So if we only want the message, no. You know what? Maybe we can use a regular expression for this. This is so cursed, but like, let's see what a regular expression for this would look like. JSON pretty is an option, huh? Yeah. Like, by the way, pro tip, regex101.com exists, and it is so good. So we can do things like take all of this, and then let's massage down a regular expression. So in DHCP, first we want the discovery, but in this case we may actually, so in DHCP the protocol is basically like, first the VM tries to send a discovery packet to the broadcast MAC address to try and figure out if there's a DHCP server at all. And then the DHCP server will reply with an offer for an IP address, and then the target machine will attempt to ping itself twice, and if that doesn't work, then it will send a request to the DHCP server with that information, and then finally, if everything's good on the DHCP server side, it'll send an acknowledgement. So what we probably want is to get the acknowledgement. Regex IPv4. I remember there's a specific regex you're supposed. This is it. This is the regex that you're supposed to use for IPv4. Or does that not work in? It doesn't work. Okay, so 0 through 9 plus dot slash dot. Yeah. Okay, that will extract that, and then 0 through 9, A through F, colon. How does that not match? Dot star. Oh, no. Or is Colon a magic character now? No, Colon isn't a magic character. You need... Oh, you need 2 hex to... I am a smart. I am very smart. I am the most smartest of the smart. You had a problem. I think I will use regex. Now I have 2 problems. Oh, with regex you have a lot of problems. I don't know if I need this 3rd group here. Might be interesting to collect it, though. I assume these are not offered as structured field in the journal message. Yeah, DNS mask is a bit too old to, like, directly log structured data to journal D, sadly. Can't you just print in JSON and extract the key you need? Okay, let's show you what happens when I do that. Okay, so in this case, I have a DHCP acknowledgement for the other VM on this network named Senna. And this DHCP acknowledgement takes, yeah, like, you know, the message. Oh. So if I look at this just JSON directly, we have the machine ID, we have the DNS mask executable. No, I don't need to do that. What I need to do is S that, and okay. So we have the machine ID, which is some random UUID v4. We have the EXE, which is DNS mask, not totally useful here. We have the source timestamp, we have the syslog timestamp, and then we have the message. This is the message. This is all I get. I have to extract the information out of the message somehow, and I'm pretty sure that doing it with a regex is like the least harmful way. Because at some level, this is what we're going to be seeing here. We're going to be seeing just all of that. So let's implement this. This is a horrible idea. Let's implement it anyway. So let's go over to esikid.go and let's do DHCP map.go. var. It is DNS mask that does not spit out things into fields. Yes, it is quite annoying. I should really turn on drifting back to source. Drift back to normal, yeah, okay. So for this, we're gonna need to make some variables. And let's just do this the simple way, I guess. Let's have IP to Mac map string. IP to Mac equals map string, so that we don't get us in the 0 value stuff. I assume there's some library to subscribe to journal messages. Yes, there is. I forget what it is, but for this first prototype, we're just going to do it the hacky way because we live on the edge here. So what we're going to do is we're going to make a function called stream_syslog that will take in a context and the program that we should be looking for, and then it'll return an io.reader, which is like, you know, something that you can read from, and maybe an error. So then what we can do is we can do cmd : exec dot command context for the context, and first we look up journal cuddle in the system path, exec.lookpath, and if that fails, then return nil format.errorf, which is how you create error, like anonymous errors in Go. I hate it too. And this %w specifier is how you wrap errors with format.errorf for some reason. But once we have this, then we can give it the journal cuddle path, and the exact command that I was using was -f_com equals DNS mask. Okay. Command.standardout, or I need to make a net.pipe for this, I think. Would the filter to one field version be better? Probably. But it's not letting me just only get the message. Oh, cat only shows the output of there. Output cat. Okay. -- output cat is what we want, I guess. Okay, how do I make a pipe in Go? I think it's in the net package. Ah, yes, pipe. Cool. Okay. So, := net.pipe. Reads on one end are matched with writes on the other, copying data directly between the two. There is no internal buffering. Okay. So I want the standard out to be the writer. Let's make that a read closer just to simplify things. I think Zeal has Go language manual. I don't know what you mean by that. So then we want to kick this off in the background with command.start, and if there's an error, return nil format.errorf ant thing. Then we want to return the reader and nil. Okay. read in parts DHCP. And then we do reader io.read closer. And since it's going to be spawned in a Go routine, I don't know if we need to have it return an error here. Probably should anyway. Then just have like some sort of like crappy wrapper, see if it returns an error, and if it does, then explode very loudly. So since this is going to be in its own Go routine, what we can do is for select case input from context.done break error return nil default continue. Did the first one need to return a recloser to pass on this one? Probably not. Let's just refactor that out. You have a good point. So then go read and parse DHCP context, and we pass it the reader. Close the reader, and now we can do our parsing stuff. So now taking this regex from earlier, God, this is a horrible regex. Regex.must compile, paste all of that in. Okay. So there's a thing that buffers things into a reader that buffers things into lines in Go. I forget what it's called. Let's look in package IO real quick. IO. Or is it buff IO? Yeah, I think it's buff IO. Ah, yes, read line. Okay. So a buffio.reader is a buffered io.reader. And we probably want a buffered io.reader here so that we can get lines. So let's try this. Let's go over to the readline function. Oh, most callers should use read string instead or use a scanner. What is a scanner? New scanner returns a new scanner to read from R. The split function defaults to scan lines. No, it's a case where Go is generic, it's just different. Okay, so if I do this, then I have this, and then if I add a new scanner to the reader, for scanner.scan, line colon equals scanner dot, I think bytes are easier to deal with the regex. No, text is fine. We get the line and then DNS mask parser dot, I think it's split is what I want. I remember there's a gotcha here with regular expressions. I don't remember what it is, but I remember there's a gotcha with splitting for capture groups. Or is it find string submatch? Yes, it's find string submatch. Okay. Find string submatch. We'll call this parts equals that, and log.print f % hash v for parts, I guess. Okay, now that we have that, let's add this to isekai.go. Go stream syslog context to DNS mask. I don't know if this is gonna work, so let's find out. Oh, hey, cool, it does work. Fucking sweet. Okay, so oh, damn. Okay, that's actually a lot closer than I thought it would be. So, with this function, the first return is the whole string that matched. And then we have part 1, part 2, and part 3. So what I need to do is I need to get part 2 and part 3. Oh, damn. Okay. That was easier than I expected. That makes me worried I'm doing something wrong. IP to maclock.lock, IP to maclock.unlock, IP to mac sub, or let's label the parts. So the first part is that, and the second part is that. Okay. 1 mac adder equals parts sub 2 IP equals mac adder. Oh, right, I have to do a colon equals here. Don't forget to skip if you got back nil. Yeah. Good point. Awesome. And let's add a little HTTP route to dump that. So mux.handlefunc /debug/ dump IP to Mac, and we'll have a response writer and a request, and we make a little thing here. JSON.new encoder w.encode. It would be IP to maclock.rlock defer IP to mac r unlock, and then we need to code IP to mac. Do that. I think that'll work. Let's try it. Awesome. Awesome. Okay, and now here, what we can do is... Oh, it's hydration time. You hit the button, I must redeem. Hydration has been achieved. So, first we lock it for reading. Then we unlock it from reading. And then we do Mac adder OK colon equals IP to Mac sub remote adder. If bang OK log.printf can't find address in map. IP to Mac list mapping. And we do present sign S, and that's going to be that. Okay, so then if we run this, rebuild ESIC-ID, of course. Yeah, and then we're going to get that we don't have that IP address in there. Good. It's failing in exactly the way I want it to. Okay, so now we're going to need to figure out the fun, magical world of IP tables. And oh god, this is going to be a thing. So let's dump the IP tables rules again. Okay, the virtual network driver, MAC filtering. Ah, right, I need to do this. There's an entry in the post routing chain. What is the post routing chain? Network filters. This was written by the libvirt guys at IBM. That's... Oh, so this is for, like, filter rules like, you know, don't let people connect to SMTP. Okay, I could see that being useful elsewhere, but what I'm trying to do is I'm trying to, like, bypass that. I don't want nested DMs. Insert IP tables rule at top. Okay. So maybe you want to insert it to the top of the chain. So let's potentially break stuff. Oh, allow specific IP to bypass NAT. Just add the bypass above the redirect rule. Don't think I'm using redirect though, I'm using contract. Let's keep that tab open just in case it's useful. Let's add the bypass rule above the redirect rule. Is it doing something I'm not anticipating? But maybe it is just that easy. Let's try this, I guess. So, no, alright, let's just edit this in Emacs. Libvirt forward in source. We only see browser, yeah. Sorry, professional internet streamer. Okay, so damn, I just found about you, so happy you're live. Welcome to the stream, Fedic24. Okay, so the forwarding input, forwarding inbound traffic, so that'd be traffic from ESXi to the VM managed by WaifuD. So 169.254.169.254. Protocol is TCP. I don't think this is it. Let's Let's double check this random DigitalOcean tutorial and see if it has what we're looking for. As network traffic generally needs to be two-way to work properly, it is typical to create a firewall rule that allows established and related traffic so that the server will allow return traffic for outgoing communications. Okay, so I do actually probably need to have the NAT/post routing table. Sudo IP tables -I or -t nat -I post routing. Limbert _FWO. Destination is 169.254.169.254/32 -J accept. Maybe. -D is the destination, right? Yeah, D is the destination. Okay. So let's SSH to this VM and see what's up. Oh, right. I don't have Tailscale on there. Okay, so yes, that did not do what I think it did. Try -T nat. Okay. Let's try -T nat. Oh. Oh, that's where it is. It's in -T nat in PRT, which I assume is the post routing table. Is that failing because there's no return route? Sudo install mtr. It's tiny. Actually, you know what? Let's have mtr run a continuous thing. Okay, so it is getting to Numa, which is what I want. But then it's failing to get to there. Or do I need to do -30 here? So... God, how do you delete stuff out of a chain? So if I name the chain like this, can't use -name with -s, okay. Oh no, that creates a new chain. How to list and delete IP tables firewall rules. You know, the real hero of this stream is all these goddamn DigitalOcean tutorials. Deleting rules by specification. Oh, so I can turn this command that I know didn't work into a command that I know will work. Okay, so I do -d. Let's try this. Okay, does that make it get through? No. Okay, that did delete the rule from the chain. But can I do this? Okay, I can. I do it with quiet curl, yes. Okay. So if I insert this rule, or no, I don't insert the rule. I do that. And it stops working. Okay, so that IP tables rule is bad. God, it would help if I knew what, like, any of these tables names meant. Forward mode equals open. Oh. Is this literally not documented? Of course it's not fucking documented. Oh, it's... YOLO, set this up yourself. Good luck. Ugh. I don't think we're getting to the struggle level of using a translated, machine translated thing from Chinese, but we're getting close to there, fam. Okay, maybe this rule has to be able to be fixed somehow. So, what this is saying... Okay, so what these chains are saying is so that in the table nat, for the chain libvirt underscore PRT, which I'm assuming is post routing, we have the source is this, and the destination is this, which I'm assuming is the multicast range. So allow that to go through. And we have the source is the VM network, and the destination is the broadcast address. Allow that to go through. So if the source is the VM network and the destination and not the destination is the VM network, then we want to masquerade to this port range. Same for UDP and same for, I think that's ICMP. Yeah. The -J line above makes it a post routing table. Okay. Oh, yes, it does. Okay, I see. So when we do the post routing, we join it to this chain and use that as a function. Okay. Okay, what does return mean? Oh, return means, it's literally returning in a function. Okay. Accept means to let the packet through. Okay, so... I feel like I'm missing something stupidly obvious. Wait. Add bang d IP to the masquerade rule. Oh. Oh, wait, hold on. Let's try something super stupid. Let's try something incredibly stupid. If this works, I'm gonna laugh so hard. Multiple -D flags not allowed, you son of a bitch. Same thing with return? Okay. Oh, right, that's -D. Okay, I want dash insert. Okay. Yeah, that's not working. Yeah, it's trying to connect and it can't. Okay. No clue, but thought it was worth a try. Yeah, I mean, I appreciate it. IP tables, multiple -D flags not allowed. For problems of this kind, you can create new chains and jumping between them. You can use comma-separated values with -D? Okay, so would that mean that, like, it would be this? Bang not allowed with multiple source or destination IP addresses. You asshole. You could consider to change the default rule set from allow to drop. You can use an IP set? That's horrifying. Oh, this is horrifying. But yeah, when I remove that, then it works. Even if we get this working, don't we have the issue of Libert not setting this up for us? Okay, so the pro gamer move that I am coming up with is once I have a command that gets this working, I'm going to have isekai try to delete that old rule and then try to put in that new rule. Like, you know, automatically try to delete both the pristine rule that is certainly wrong and its new rule that is less wrong, so that it will, like, you know, manually unfuck everything. Okay, I probably do have to use an IP set. So let's see what the hell an IP set is. Let's add IP set to the shell, just in case. I wish the XML was more configurable. Me fucking too. So much. Okay, so administration tool for IP sets. Oh, helps to show the thing. Just buy a USB Ethernet adapter and pass it to the VM. Would require interactive debugging, TBH. You know what? There's an expert that is trying to help me on Twitter, so I just linked them to the stream, and let's see what happens there. Okay, so... Pretty sure this is multicast. Pretty sure this is broadcast. And this is the one that's doing the NAT translation rules. Oh, wait. What if... Oh no, did we try this one already? I think we tried this one. Or no, we didn't try this variant of it. So if we follow the vibe of the rest of these, we can say that the source is that and the destination is that. Now, does that work? No.